Okay, let's do these exercises. So using your calculator, make sure you're in degree mode. Sine of 1, it's said to round to 4 decimal places, so that would be 0.0175. Sine of 30 gives us exactly 0.5. Sine of 45 gives us 0.7071. Sine of 60. So our ratios are getting higher when our angle gets higher. Sine of 60 is 0.8660. Sine of 75, 0.9659. Sine of 85. So you'll note we're getting closer and closer to 1 because our opposite side is getting closer and closer to the length of our hypotenuse. So sine of 89 should be very close to 1. And it is 0.9998. Okay, we can do the same kind of thing with cosine. So cosine of 1, now our adjacent relative to our hypotenuse is close to 1. So that's 0.9998. Cosine of 30 gives us 0.8660. Okay, you might notice some of these numbers are in common between sine and cosine. There is a pattern there. And if you're interested in that pattern, or you're interested in learning how to calculate some of these angles without your calculator and find the exact ratios, I encourage you to go on further into math 56, and then math 60 is really where we get into that. So cos of 45 is 0.7071. Cos of 60 is 0.5. Cos of 75, 0.2588. Cos of 85, 0.0872. And cos of 89, 0.0175. Okay, next question. We're asked to solve for side length x. And so it gives you kind of a guideline of how to do that. So first we're going to name side x. So relative to this target angle 30 degrees, we're looking at our opposite. And here the 40 is our hypotenuse. So we want to use a ratio that involves opposite and hypotenuse, and that's going to be sine. So we know sine of any angle theta is opposite over hypotenuse. So sine of 30 degrees is going to be x over 40. And then I'm going to multiply both sides by 40 so that I'm left with just the x on the right-hand side. So I get x is 40 times sine 30. And we've been told to round to 1 decimal place. In this case, it's an exact 20. So just 20. Okay, next one. So let's label our triangle first. So relative to that angle 25, x's are adjacent, and we've been given our hypotenuse. That means we're looking for a ratio involving adjacent and hypotenuse, and that's cosine. So cosine of any angle theta is adjacent over hypotenuse. So cosine of our angle 25 degrees equals x over 13. And then we want to solve for x, so we're going to multiply both sides by 13. Or cross multiply and bring that 13 over as you wish. And so we have 13 times cosine 25, and to 1 decimal place, that gives me 11.8. Okay, next one. So let's label relative to that 60 degrees. X is our opposite side, and 9 is our adjacent. So in this case, we're actually using tan, the tan ratio, because we want one involving O and A. So tan of our angle theta is opposite over adjacent. So tan of 60 degrees is x over 9. And we can multiply both sides by 9. So we've got x is 9 times tan 60. And to one decimal place, that gives me 15.6. All right. Relative to the 70 degrees, I've got my opposite and my hypotenuse is my unknown here. So I'm looking for a ratio involving O and H, which is sine. So sine of any angle theta is opposite over hypotenuse. So sine of 70 degrees is 142 over x. So let's multiply both sides by x to get it out of our denominator. Okay, so now I've got x times sine 70 equals 142. And to isolate the x, now I'm going to divide both sides by sine 70. My sine 70s are going to cancel on the left. Whoops. Uh-oh. Where did it go? Come on back. No. That wasn't good. There it is. Okay. And so, sorry about that. Now we've got x is 142 over sine of 70. So we can do that calculation. And we get 151.1. And that makes sense because we expect it to be the longest side in this triangle. So it has to be longer than 142. Okay, next one. So relative to the 17 degrees, I've got my adjacent side over here, and then my hypotenuse is x. So I'm looking for a ratio involving adjacent and hypotenuse, and that's cosine. So cosine of any angle theta is adjacent over hypotenuse. So cosine of 17 degrees is 91 over x. Let's get x out of the denominator by multiplying both sides by it. Okay, now I've got x times cos 17. That should be a little x. Equals 91. And so I can divide both sides by cos 17. Should put that degree symbol in there, so I did. Okay, that cancels my cos 17s from the left. So I'm left with x is 91 over cos 17, which I can calculate. And it gives me 95.2 out to one decimal place. Okay, last one where we're solving for side length. So let's label this thing. Relative to my angle, 3.6 is my opposite side, x is my hypotenuse. So I'm looking for a ratio involving O and H, which is sine. So sine of any angle theta is opposite over hypotenuse. So sine of 72.5 degrees is 3.6 over x. Let's multiply both sides by x to get that x out of the denominator. Okay, so now we're left with x times sine 72.5 equals 3.6. So now let's divide both sides by sine 72.5 degrees. Okay, so x is going to be 3.6 divided by sine 72.5. And out to one decimal place, that gives me 3.8. And that makes sense because I expect my hypotenuse to be longer than my 3.6, which was my opposite side. All right, on the next ones, we'll calculate angles. We'll solve for angles. So give those a try and then come back to do them together if you like.